Hey guys, so we're going to be looking at an idea on parabolas and circles. So really just a continuation of chapter 10. But there's a big concept within these that really strongly links parabolas and circles together. And this will be a big part of something that you're going to be doing in Algebra 2. And so we're going to take a little time to go through these two types of functions. So we're going to start with just parabolas, and we're going to go through a few lessons on this, and then we'll come back to circles, and you'll see a very similar process that we'll be using with circles and how these guys relate to each other. So let's just start with our basic idea of a parabola and what it looks like, and then we'll talk about sort of the specific important characteristics of a parabola. So a parabola is really a graph that takes on a U shape to it, so like this one that you're seeing right here. So the vertex form of a parabola is what we're going to be talking about. There's two different ways you can write, well, there's multiple ways you can write the layout for the function of a parabola, but we're going to focus on one specific type, which is called vertex form. So let me write that out for you, so you guys can fill this in with me. So a times x minus h, quantity squared, plus k. Okay, and so we'll be kind of laying out the different ideas that you're seeing from those letters. But the first thing we're going to talk about is the vertex of the parabola. And there's a reason this is called vertex form. The vertex is the point that you're seeing right here. Right? Currently it's at 0, 0. So it will either be the highest point or the lowest point of your parabola, depending on which direction it's going. Right now it's the lowest point. It will always be the center point of your graph, of your parabola. Okay, and so what you're seeing within this layout right here is the coordinates of that point consists of h and k. So h is going to represent the x coordinate of your vertex, and k is going to represent the y coordinate of your vertex. So the vertex, if we really put it together, would look like this. So whatever number you see sitting here is going to be the x-coordinate, and whatever number you see sitting here is going to be the y-coordinate. One of the huge issues that you're going to see on this, and it's going to be the same when we get to our equation of circles, is you need to notice within the layout of this formula that there is already a minus sign sitting in front of h. So what you're seeing here is just the h value without the negative. So in other words, when you really start throwing some numbers into this, this number is going to be the opposite sign of what you see right here. You'll notice this says minus h, and right here is a positive h. So the easy way to look at that is simply that this will always be the opposite sign of what I put here for my x-coordinate. And we'll look at some of those here in just a minute. So the axis of symmetry is an invisible line that runs vertically right down the center of your parabola. So we're going to be using this line down the road when we are making our own graphs. But the key thing is it splits your graph perfectly in half. The left side of this graph is a mirror image of the right side of this graph. Every point that you see on this side has a mirror image point on the other side, and they're the same distance from that axis of symmetry. So your axis of symmetry, because it's a vertical line, so if you just think about the way you would write the equation of any vertical line, it's always x equals a number. Well, your axis of symmetry always has to run right down through the center of your graph through the vertex, right? So if it has to pass through the vertex, then the equation of that line is going to be x equals whatever the x-coordinate of your vertex is. And so we're always going to write the axis of symmetry as the equation of a vertical line looking like this. The domain, whenever you think of domain of a graph, remember domain simply represents what your graph is doing from left to right. And in this graph, when you're doing a parabola, this will keep going up and left forever. And this side will continue to go up and right forever. So if it goes left forever and right forever, that means it goes from negative infinity all the way to positive infinity. And then that's just a way of saying that it goes on forever in both directions, left and right. The range is what your graph is doing up and down, right? So as I look at this, I can see that this graph is only going upward from 0, from the vertex, right? From this value right there, right? From the y-coordinate of my vertex. So if this is 0, 0, and my graph only goes upward from there, then we might say that my range are all of the y values greater than or equal to 0. Right, in this case, and that's if my vertex is at 0, 0, and if my graph is going upward. Well, this point can move around, and your graph doesn't always go up, sometimes it goes downward, right? But one thing we can always link it to is this guy right here. So if you have a graph that is going upward, like this one, then we're going to say that our range is going to be the y values that are greater than or equal to whatever k is. Right? It's going to go upward from that point. If it was a downward facing graph, so if it was doing this instead of going up, well, then it would be all the y values that are less than or equal to k. So this is the way we can always look at the range of this graph. As far as the maximum or minimum value, again, that comes back to your lowest point or your highest point. Right? Your vertex is always either the lowest or the highest point of this graph. If it's a positive graph, like this one is, then your vertex is the lowest point on the graph. And if we're talking about how high a point is or how low it is, right, that's something that goes this direction. So we're only talking about the y-coordinate of your vertex. Okay, so if I look at my vertex, whatever that y-coordinate is, which is my k value, is going to tell me whether I'm looking at the maximum or the minimum value. So we're just going to identify that it's going to be the value of k, whatever that is. And then we're not going to get into quadratic form in this unit. We're just going to stick with those for a minute. So we're going to get into some actual graphs here. So I'm going to turn my page over to the back side of this one. And there are 6 problems on this page. And I'm going to go through some of those with you right now as the lesson, and then the remaining ones are going to be for you to finish on your own as the assignment. There's 3 things that we're being asked to do on this. We need to identify the vertex, we need to identify the axis of symmetry, and we have to graph it. So we need to do all 3 of those. Okay, and we'll get to the graphing part here in just a minute. So let's just start with the vertex of this graph. So remember, if I look back at where my h and my k values would go, in fact, let me write this at the top so I can kind of refer to it. So here's kind of the general format that we were seeing on the last page. So remember what I said about, I'll say vertex, and let me just open up these parentheses. So when I look at my vertex, remember your vertex consists of h and k. So my h value is going to be sitting right here, which is the one that I see. And then my k value is the one that's sitting here, which in this case is going to be that -3. So if you just look at this form, and this is what's super important. If you guys notice, that negative was already there, right? So if I just said what number is sitting in place of h, then we would just say, well, there's a 1 sitting there in place of h. The negative was already there, right? So there's a +1 sitting in place of h. Really, the easiest way to remember this, like I said earlier, is your h value is always going to be the opposite sign of what you see right there. Your k value, however, we're just going to take it at face value because this guy was a positive k in the original form. So we're just going to take whatever value I see here as my y-coordinate. So there's the vertex, right? So the vertex of this graph is at 1, -3. Right there. All right, what about the axis of symmetry? Remember, there's a vertical line that runs right through the middle of this graph, right through here. So remember, that vertical line we always write as x equals whatever h is, right? So x equals h is the equation of that line. So we're going to say axis of symmetry. So I'm going to abbreviate that. AOS, so axis of symmetry. And we're going to write it as x equals whatever our value for h is. So there's a vertical line that goes right through x equals 1. It looks like this. That should go right down the heart of our parabola. There's one last piece to this that we're going to do for our graph today. So where do I draw the curve? Some parabolas will go upward from your vertex, and some parabolas will open downward from your vertex, like this. Right? So how do we know if it goes up or down? That's where this guy comes into play. If your leading term is positive, then you get a positive parabola. It goes upward. But if your leading term is negative, like this one is, then our parabola is going to open in the negative direction, which is downward. So because this is a negative, here's my vertex. I want to go downward from my vertex. And for today, we're just going to keep it as a simple sketch. I'm not actually going to plug in some other numbers here to get other points on the graph. We're just going to limit it to just that information for today. I'm going to do 2 more with you, and then I'll leave you numbers 4, 5, and 6 to do on your own. So if we look over at this one, make sure we identify the vertex. That was part of the directions. Remember that your h value is always the opposite of what you see right here. So in this case, it's going to be -1. And the k value, we always take at face value, so -5. So there's our vertex. I know my axis of symmetry always runs right down through the middle of my graph. So in this case, let's plot that point first. -1, -5 is our vertex. And so my axis of symmetry needs to run right down the center of my graph through the vertex. Okay, so in this case, my x-coordinate is -1. So we're going to say x equals -1. And that's going to be our axis of symmetry. All right, so the only other thing we have to decide now is from our vertex, should this graph open upward or should the graph open downward like the last one did? So remember, it comes back to your a value. So if I look right here, I'm basically looking to see what sign is sitting in front of this entire equation. So right here in front of my parentheses, well, there's nothing there, right? So we know that it's positive unless there's a negative written. Okay, and so if there's no number that I see here, it's like having a +1 sitting there in front of our parentheses. So as long as it's positive, I know this graph should open upward. And I always want to try to make the right side look similar to the left side. Now this is just a sketch. If you were to actually come up with some more real numbers on the graph like we're going to do in our upcoming lessons, we'll get a more accurate curve. But this is as far as we're going today in the details of it. There's one more I want to go through with you, and then I'm actually going to show you an online tool that's really nice as well. So just keep in mind, guys, if your vertex is sitting at the top of your graph, we would call this a maximum. And our maximum value would be this guy, so -3. If your vertex is at the bottom of your graph, then we call it the minimum, and the minimum value would be -5. So it's always the y-coordinate of your vertex. We're going to do one more together, and I'm going to show you how you can see some of this online as well. So as you look at this one, again, we want to identify the vertex and axis of symmetry. So my vertex, I want to take the opposite of that for my x-coordinate, so +3. And I want to keep this as it is for my y-coordinate, so -2. My axis of symmetry is always x equals h. So there's our axis of symmetry. So let's plot our point at 3, -2. I know I have my vertical invisible line going through x equals 3. So it looks like this. Should split my graph in half. And if I look at my a value, I can see that my a value is a negative. So I know this graph should open downward from my vertex. So again, I want to try to make the right side look identical to the left side as much as I can. And that'll be good enough for now. So you guys are going to be doing the remaining 3 on your own. But I do want to show you a way that you can always verify a graph, any graph. So let's just take the one that we just did. So I'm going to do y equals -x minus 3 squared plus 2, minus 2. And if you haven't seen this before, a great website called Desmos. So if you type into your browser desmos.com, it'll take you to Desmos. And then right in the middle of that page, you'll see a blue rectangle that says Graphing Calculator. Click on Graphing Calculator, and it's going to look like this. So all we're going to do is type in the equation that we just did. So y equals negative x minus 3 squared. And if you need some of the special math features like a squared, like an exponent, you just click on the little calculator that you see right here, and it pulls up this whole menu of items that you can use. Mine's just going a little slow. So right here, I can throw in the squared, and then minus 2. So this was the equation that we just graphed. Let me get rid of the calculator. And you'll notice it looks just like ours. I can click and drag it. You can zoom in and zoom out for more details if you need to see more. But if you just click and drag, you can kind of put it wherever you want to see it on your screen. And so that's looking pretty good for what we had. If you notice right here, see that little point that comes up? There's our vertex. And if I just hover over it, sure enough, it was 3, negative 2, just like what we came up with. So it's just a great way of sort of verifying what we came up with on paper. But that's all we got for today.